Hello everyone, this is developer Ashish, and today in this tutorial we are going to make our own mask detector using deep learning. Basically we are going to use transfer learning method, and in today's tutorial for transfer learning we are going to use Mobilenet V2. I have already made another project using transfer learning, that is coronavirus recognition using transfer learning method, and in that tutorial I have used VGG16 model. Okay, so today we are going to use different model, that is Mobilenet V2, and this is a very lightweight model. Okay, this is a very lightweight model. You can use this even with your mobile phones. Okay, like if you are making any mobile applications, if you want to use it with Raspberry Pi, you can use it. Okay, this is a very lightweight model. So basically, first we will write the code for the training. Okay, we'll write the code for the training and all. I'm going to explain each line of code. Okay, I'm going to explain each line of code. This tutorial gonna be very beginner friendly, just like my other tutorials. Okay, and then see, this is the model which we are going to save. Okay, Mobilenet V2 model. I was also using Mobilenet V1 model. Basically, just a spelling mistake. Basically, Mobilenet V2 is the better version of Mobilenet V1 model. Okay, it is little slower, and Mobilenet V2 is little faster. Okay, this is the data set with mask. Okay, which we are going to train, and without mask. Okay, so first we will train. Okay, and I'm going to then write a code for the testing in the image. Okay, I'm going to explain everything, and then for the video. Okay, let me first run this, and then I'm going to explain you like what is Mobilenet basically. Okay, in just a summary, you can learn about Mobilenet depth wise. Okay, later on. See, no mask. I'm sorry. Mask. Okay, so basically that's how we are going to try this. Okay, and then after this let me first of all let me just share you that this code is taken from here by image search. Okay, you should visit this website. I'll give you the link of this tutorial or of this blog. Okay, in which where is he? Basically, in which this person has explained how all the things works. Okay, and you should visit this website. This website contains many great tutorials. Okay, so we are going to use Mobilenet V2. Okay, last time we used last time we used VGG16 model. Okay, in that coronavirus recognition. Why Mobilenet V2 is very or basically Mobilenet is you can say very awesome. Okay, and very lightweight, basically because of, see, the parameters in millions. Okay, the parameters which basically what I am talking is this. Okay, how much parameters it has been connected. Okay, like see. Okay, like you can even see like this. Okay, the total parameters is 22 lakhs, like this. Okay, so VGG16 contains 138 million parameters. Okay, this, and the size of VGG16 is, if you talk about the MB, okay, it is more than 500 MB. But Mobilenet is only about 17 to 20 MB. Okay, the size is so small. See the parameters, 4.2 million only. Okay, this the whole difference, 4.2 million and 138 million, a lot difference. Similarly, million, the multiplication and addition in the parameters in millions. See, only 569, and see the VG16 is having 15,300. Okay, but see the accuracy, even though you can see the parameters are very less, but they so when they were trained for thousands of classes, their accuracy is only, the difference in their accuracy is only 1%. Okay, see the accuracy of 71.5%, and Mobilenet is having only 70.6% overall. Okay, when they were trained for thousands of classes. So you can just see that Mobilenet, is so lightweight, and it has almost same accuracy as VGG16. Okay, Mobilenet V2 architecture is basic like this. You can learn about like how bottleneck, how depth wise training happens. Okay, in CNN you can learn about, you can go through any tutorial. Okay, so basically in transfer learning what happens is, I've explained transfer learning throughout the video. Okay, don't worry about it. But basically, let me just summarize that we cut the last layer and we add our own layer, and we remain and we keep other layers as it is, just as a feature extractor. Okay, and then we train. I've explained this thing in a detail throughout the video. Okay, so I've explained transfer learning. I have shown how to use Mobilenet v2, and you can use any model you want. Okay, and in transfer learning we keep other layers as it is. We just remove the last layer and we add our own layer, and then we train it. Okay, that's all. I've explained this in a detail in the video. Okay, okay then this tutorial is very beginner friendly. So let's start decoding. Let's start decoding from writing the code for the training, and then we're gonna write for the images, testing in images, then the testing in video finally. Okay, so let's import our libraries. Import numpy as NP. As you know, numpy is used for array functions. Okay, we can make arrays and all. Import OS because of course we need OS to access our dataset. Import matplotlib dot pyplot as plt. Matplotlib we use to create graphs basically. Okay, we're gonna make accuracy and loss graph. That's why we need matplotlib. Import paths to access our dataset. Okay, and yeah, oops, my mobile. Okay. Now let's import our CNN structures. Okay, let's import them from tensorflow. Tensorflow is a deep learning library. Under that, Keras is a deep learning library of course, and it's a API. Under that there is a folder or a file basically called pre-processing. Okay, but let's import first application so that you can applications. I should have used, I don't know why I did it, but okay. Mobilenet v2. Okay, under TensorFlow there is a Keras folder. Okay, means if you go into your Python script, Python, yeah, library folder, script, and no, if you go under your Python library folder, under that you will find side packages. Under that you will find TensorFlow, then I think Python, and then under that you will find Keras, and then under that you will find this folder applications. From that we are importing Mobilenet v2. Okay, if you want to use other architectures of CNN of pre-trained model, then you can use VGG. You just need to write VGG16. Okay, let's say you want to use VG19, or let's say you want to use ResNet 50C. Okay, so you can do this. Okay, see, we have all this. If you press tab in Jupyter Notebook, you will find like this. Okay, so we are using Mobilenet v2. Okay, Mobilenet is a very light module, light architecture. Okay, Mobilenet, which means basically we can use this one with our mobile phones also. Okay, you can read about it. This is very light. Okay, VG16 and all is very heavy, and we can use this one with our Raspberry Pi, with our mobile phones. Okay, that's why from TensorFlow dot Keras dot layers. Okay, layers import max pooling. I'll explain you. Okay, I'll explain you, don't worry about this. Now we just need this to copy. From TensorFlow there is a folder called Keras of course, and then there is a folder or a file, basically layers. Okay, there might be any folder layers. Okay, and we have we have dropout file. Okay, check the layers is a folder or file. I have not seen. Okay, but check. Under that you will find this import flatten. flatten. Okay, now again import. I'll explain you what is flatten, what is dense, what is dropout. Okay, don't worry about this. Input, which model is our input, and dot models. Okay, import what is our model. Okay, so that's why this. Now now one more thing, no, not one more thing. Okay, let me copy this one again, and applications, under applications, which one is we are having? Mobile net. Okay, v2 import pre-processing input. Pre-process input means if you press tab, you will autocomplete, it will auto complete this. See, if you are using Mobilenet v2 now, okay, of course you need to pre-process your data. That's why dot application Mobilenet v2. If you use vg16, you just need to write vgg16 here. Okay. No. Okay. Now where were we? Okay. Some more library basically from dot pre-processing dot image. Okay, we need to pre-process the image also. Okay, so this is called image data generator. Okay, means we can generate more number of data set using less number of data set. Okay, now again where is my mouse? Yeah. Import image to array to convert images to array. Okay, of course model can't take input in the photo form, right? We need to convert this into array. Okay, and import load image. Of course, first load the image, then we will convert that into array. Okay, now from tensorflow dot keras dot utils. Okay, import to categorical. I'll show you why, because to categorize them. Okay, from sklearn. Now this is a machine learning library. From sklearn dot pre-processing import label binarizer. Why? Because see, we have two categories. Okay, mask and without mask. Okay, so we need to convert them into binary form, right? To so that you can say our model can take the input. Okay, our model don't know what is mask and what is without mask, means those wordings. Okay, so we need to convert them into number form so that our model can understand. From sklearn dot model selection, and we're gonna import train. Do we will use train test? Do will we use this or not? Let's see. Okay. And many things. Is everything I do? Okay, one more thing. Okay, model we imported, but let's import from tensor tensorflow dot keras dot optimizer. Okay, means the gradient descent function. Which one? To improve our model. Adam, we're gonna use it. I'm gonna explain you. Okay, so I think most of the things we did. Let's run this, shift plus enter. Okay, everything done. Now let's you can say let's access our data set. Okay, where is our data set? Data set equals to where is our data set? Here. Okay, data set means in this face mask detector. I'll give you this data set link. Okay, data set and r, put r. Okay, data set and just this forward slash. Why r? Because Python takes everything in the forward slash, so you just put r and it will reverse and just do this one. Okay, data set and image paths. We are naming a variable image paths equals to list. I'll just show you what it will happen. Okay, paths. What is paths? We imported that here now. So go into that path. Go into path of data set. Okay. Go into list images data set. Means from paths. Okay, from paths there is a function called list images. Means make a list of the images into that data set. Okay, means see with mask you have this number of images. Okay, these all images without mask here this, and it will make it will make simple list. Okay, see this. Now if I call that image paths C, okay, C Python and project face smart detector data set without mask. Okay, then C 0 dot jpg and all 1 jpg, and you will, if you go down, you will see see with mask. Okay, with mask and image number and all. Okay, dot jpg and all. Okay. Now okay, so now we have our images, but see, to give our model to train. Oops. Okay, so now we have our images, but to train our model we need x and y. What is x and y? Basically x is our you can say, is it downloading? Yeah, okay, x is our images, y is our labels. Okay, so that our model can see, okay, this is the image of without mask. Okay, and what is the label? Without mask. Okay, so now we need x and y. Now what is x and y? X is our images and y is our labels. Okay, means see, this is the images. Okay, our model need images plus its labels. Okay, so that it can differentiate. Okay, if something mask type of thing is there, then I need to label it with mask. Okay, and if there is no mask, then it is known as without mask. Okay, so let's create our x data and labels is this. Okay, the blank list. Now let's do one thing. Basically let's separate images with its labels. Okay, so for I in image paths, okay, means basically this I will go to into this image paths and it will separate them based on the labels, and label is equals to, okay, not labels but label is equals to label is equals to I dot split split into os dot path dot separate with -2. See, why -2 is basically here. See, this I will go to this image paths. Okay, and it will get split with according to the label. What is label? With mask and without mask. Why -2 is, this is our image paths. I will go here, -1, this is your image basically. Okay, indexing starts from -1 in reverse order. Okay, and -2. Okay, so this I will be this name without mask, and similarly with mask. Okay, it will be the -2. Okay, so let's do this, and we will do something about the data, but see the labels. Okay, labels, but one more thing here, labels dot append what? Label, means this label will get append to this list. Labels dot append labels. Okay, means it will just go there. Okay, now see the labels. See, data set without mask. Okay, without mask and all, and okay, this is why this data set fine. Okay, do this. Oh, yeah, just don't put that. And now image paths, and we ran this. Okay, now it's okay. Means it was just a slash problem. Okay, so now we have our labels ready without mask and this with mask. Okay, this -2 is basically this -1 and then -2. Okay, now we have appended our labels. Basically we have appended everything into this list labels. Okay, and we will use label binarizer here. Okay, so that we can binarize it, we can give it a number 0 and 1. Okay, now let's do something about our data. Basically, okay, image is equals to load image. Okay, we did for y, this is our y. What is our x? X we are doing right now. Image, uh, image not paths I. Okay, I go to I means of course it will this image paths. Okay, and it is going in every image. It has separated the labels. Now it's time for the image 224 by 224. This is our image size we are giving it. Okay, what is this? Basically, see, every image size is different. Okay, see, 525 into 350, 510 into 340. Okay, model need a particular image size to train. That's why we are defining a particular image size 224 by 224. Okay, now this is a very standard image size. Now image is equals to, and now we have loaded our image. Now let's convert them into array. Okay, array and see. Now see, if you call the C, every image has been converted into array. Okay, see, because we can't give our model pictures to train, we need to convert that into numbers, into array. Okay, now one more thing, image is equals to pre-process input. Now pre-process it according to the mobile Viginet which we imported it, this one. Okay, now let's me run this again, and now let's see this. Okay, the size got smaller, values doesn't. Okay, earlier it was 224, it was the bigger in size. Now see, now it's 0.0 and all. Okay, means this reduces the size of the input to the model. Okay, means values doesn't change. Okay, if it's a pixel value, if there is a pixel value, it will not change. Okay, but the size will get reduced. Okay, it will get scaled down basically. Okay, so that we can give that to our model. Okay, now this is all your images. Now append that into data dot append what? Image. See, now data, you have your data basically. Okay, this is your data, this is your x, and this is your y, this labels. Okay, now let's move ahead, and now see, this is your x. Okay, this is your data, but we need to convert that into numpy array. This is in the array, this is in the array form, but we need to convert that into numpy array and labels also. Okay, data is equals to numpy array. Okay, numpy array, convert what? Data with the dimension type, or the, you can say, yeah, dimension type float 32. Okay, and labels with numpy dot array labels. Okay, convert labels and store them into labels again, and similarly convert them and store them into data and labels. See, you will not see much difference, but only see 4 square bracket 1 for this 1D, 2D, 3D, and it's kind of 4D array. Okay, but it's a numpy array, and see here you will find only 3, 1, 2, 3. Okay, but see, it was like in the list. Okay, it was like in the list, it was in the list. Okay, see, data. What is data? List. Okay, this one. To train our model, we need not in list but in the numpy array, with basically in the array. Okay, so it was in the list and we converted that into an array. Okay, similarly labels was in the list. Okay, labels was in the list. See this. Okay, if you run this, it was in the list. Now it was in the square box. Now it's an array. Okay, see the parenthesis. Now it's an array without mask, dot means all the files, and then with mask. Okay, now x and y is not totally ready. Now y will be ready. Okay, y will be totally ready. Now labels, not label, but let's call label binarizer, and I am storing that into lb function. Okay, label binarizer, this, that's how you call any class. Okay, and storing into lb. Labels equals to lb dot fit transform. That's how we transform that. But so why type function not working? Transform the labels and store them into the labels again, and labels is equals to C. First it will read the labels. Okay, fit transform means it will first analyze the patterns, okay, labels, and then in what we need to transform it, categorical 0 and 1. Okay, labels C. Now if I run this and labels C, see it has been converted into 0 1 and 1 0. Now it's in the numerical form. Okay, now model can understand this. 0 1 means if in the x, let's say okay, if in the x the model takes this as an input and it will take this one as an input, means okay, it will for absolute beginners I am explaining you. Okay, this is your x. Okay, this is your x and it is its labels. Okay, so your model is taking this in the numbers and it will find the patterns and it will recognize this as okay, this is 0 1. Okay, similarly it will take this and it will recognize as 1 0 and it will give output in the human form, in the human language. Okay, without mask, with mask. So basically our x and y is ready to go into the machine learning model basically. Okay, so we have now let's split our data for training and testing. Okay, let's split our data, train x. Okay, and now what gonna happen is basically train y and test y. See, let me put underscores to understand better. See, what happens is now all the images will be getting splitted into training and testing with its labels. Okay, train x means we gonna split our data with its labels, 70% for the training and 30% for the testing. Okay, not 30 but 20% only, and 80% for the training, 20% for the testing, 20% for the testing, so that we can understand how well our model performed. Okay, so x train means basically x train means the 80% images, test x means the 20% images, train y means the labels of the 80% images, and test y means the labels of the test x, the 20%. Okay, split what? Data, split the data with its labels, and test size. What should be your test size? Basically 0.20. okay, and random state means whenever see. So basically, if you give random state is equals to none, means you, if you don't give any integer, whenever you will run this cell, na, your training and testing data will get splitted randomly different every time. Okay, so just give an integer so that whenever you run this cell, okay, you will get same type of data. Okay, so just give 10 so that your data can match with my data. Okay, and one more thing is basically one last argument you need to give here is stratify. Okay, what is stratify is basically, see, what is stratify is equals to labels. Okay, what is this basically? See what is stratify is equals to labels means, let's say if there are 40% without mask in the labels and 60% is with mask, so when you split them, na, it will make sure that you get 40%, 40 and 60 ratio in the splitted data. Okay, train x and test x. Okay, means you will get 40% without mask here, 40% here, 60% with mask, 60% with mask here. Okay, means if there are 40-60 ratio in the labels, you will get same amount of data. Okay, say in the same ratio. And for input variance number of samples, now what could be the case? What's the matter? Okay, so after searching for 30 minutes, what I was doing wrong is basically two things only. This line, okay, this line, where it is, should be under this for loop. Okay, this and this one. Okay, this and this one. Let me rearrange that. This, this. Okay, means under for loop, for I, that I will go to the image patch and it will split the labels, okay, into this. Okay, means it will get split with image and labels. Okay, and it will append the label in the labels list, and it will load the image, every image in the for loop. Okay, this is in the for loop, it will load every image with this targeted size. It will convert into array, it will pre-process it, and it will append those images here. Now let me run this again and see. I was doing many things, trust me. So after that, let's run this data. First let it run. Okay, it's going on, the for loop is going on, and yeah, now see. See, okay, the list of arrays of images means the images array. Okay, this is the array, and this, see, okay, under square box means under list we have arrays, under list we have labels, and let me cut it. I was just trying, okay, I was just debugging. So now this was data. Okay, data. What was the problem? Basically, see what was the problem is, we didn't, like, see, in considering number of samples, 1, 1376. Actually, it was not in the for loop basically, so that's why. So now if we run this and data dot set, see, 1376. Now our x is also 1376. Okay, label, these are labels, and yeah, we did. And now let's split them. Okay, now train, it was just a small mistake. Train x, see, these are 80% training data images. Okay, with train y, its labels 80%. Okay, and see, 80% y, basically, see, earlier the size of the label or the data both was 1376, right? Now if you look at the size of anything, see, 80%, not basically, see, data .sige, not size, but sorry, the shape, okay. See, 80% of, you can say, and it's not also say, it's say 80% of this of 1376 gonna be 1100. Okay, so now this 80% of the training images and labels is now stored in train X and train Y. Okay, and similarly test X. Okay, this is the rest 20% which we will use for the testing, and they are its labels. Okay, 80%, sorry, the 20% is 276 only. Okay, similarly you can find here 276 comma 2 means the two column. There are basically two categories. Okay, two categories. So 1100, and these are the image size 3. 3 is the RGB. RGB means the colored image. They are colored image. Okay, so now we have our data ready. Okay, now we just need to do image data generator, means generate more number of data with this number of data. Okay, so our train test variables are ready basically. Okay, so now let's do one thing, is use our image data generator to generate more number of images. What does that basically say, and what does it do is very important. Okay, see, for training we have 1100 images. Okay, what it will do is basically it will generate more number of images, using all the images. Okay, like see, rotation range is equals to 20, means it will rotate by 20%. Okay, see, it will take the first image and it will rotate it by 20%, means it will generate the second image which is 20% rotated. Okay, zoom range is equals to 0.15, means it will basically zoom that image by 15% and the third image will be formed. Okay, and width shift range. Okay, if you press shift plus tab you will see all the parameters. Okay, like see all the parameters you can give. Okay, width shift range and all. Okay, so tab width shift range, it will shift the image. Height shift range means it will shift the image by 20% with respect to width and height. Okay, shear range is basically it will shear the image. Okay, horizontal flip basically, what does it will do, it will flip the image horizontally. You can even give vertical flip also. Okay, so you vertical flip is equals to true. Okay, fill mode is equals to nearest. Okay, means it will just fill it up nearest. Okay, see how many parameters you are giving, 1 2 3 4 5 6, and means from one image you will get 7 to 8 to 9 number of images. Okay, so you can say your data is now large enough. Okay, see if you call this yeah, see image, it's just a function basically. Okay, now it's okay. Now we have applied image data generator, we have our training and testing variables. Okay, train X, train Y, test X, test Y, we have that. We have applied image data generator with we have basically we have stored this in the AUG and we will apply it later. Okay, we have defined it, we have defined the parameters, we will apply it later. Okay, now let's make our CNN basically, right? Now what is our pre-trained model? Base model is what? Mobile.net. Okay, mobile, not .net but Mobilenet v2. Okay, weights, let me explain what is this weights. Okay, image net. Okay, with this line of code your Mobilenet v2 will start downloading. Okay, I'll show you how, I'll show you where it will download. Okay, include C. Okay, let me first explain this. Okay, now what is ImageNet? Let me first explain this. What is ImageNet? Okay, see, ImageNet, or if you can see, every year there is a competition called ImageNet where many people come with their CNN architectures. Okay, and you can say Mobilenet v2 is one of the most highly recognized CNN architecture. Okay, like which applied, and it might have even won the ImageNet competition. Okay, and if you look at the Mobilenet v2 architecture. Okay, if you look at it, okay, see. So every year there is a competition where many people come with their architectures to apply in that competition, to compete in that competition, and Mobilenet v2 is one of them. Okay, and see, if you look at the architecture, okay, it is very lightweight. We have Mobilenet v1, but it is little slower, so we are going to use Mobilenet v2. Okay, you can watch any tutorial like how it basically works. So see, let it load. Okay, yeah, see, not this, yeah, it's okay to understand, but okay, so see, what happens is, now basically this is the architecture of Mobilenet v2. Means first conventional 2D layer will be there. Okay, then the bottleneck, then this, then average pooling. Okay, so we need to apply average pooling because this one Mobilenet v2 applies average pooling. Okay, not max pooling. I'm sorry about that. Import average pooling 2D. Okay, so now basically average pooling and then conventional 2D. Okay, what we will do is basically we will remove this last layer. Okay, we will remove this last layer because see, the image not competition. Okay, this model was trained with other models for thousands of classes to recognize thousands of classes. Okay, so in the last layer it is having the memory of thousands of classes, but how many classes does we have in this data set? 2 with mask, without mask. Okay, so we just need to remove the last layer and add our own layer. Okay, so see, include what we need, what we need to do is basically see, weights is equals to ImageNet. Why? Because of course it has been trained for thousands of classes in this ImageNet competition, so we are downloading its weight. Okay, its memory, its the feature extraction thing which I am going to explain you, and we are just means we are going to download its good part, but we just need to remove the top layer. Okay, means the last layer, that is false, don't include. Okay, and what is in what shape we want to download. Okay, tensor is equals to input wait, what is the shape basically of our image? You remember now, we took it 224 by 224 by 3. Why? Because we have RGB images, means we have colored images. Okay, so see, when you will run this code now, your model will start downloading and it will get download here. Now you just need to remember two things. See, in the Windows 10 users, your username, like I have Theoro dot keras models, and you will see Mobilenet v2 is already there. Okay, if I let's say if I cut it, and let's say if I just paste it here. Okay, now it's not in the models folder, so it will start downloading. Okay, but see what happens now. Sometimes problems occur, like sometimes problem occurs like internet problem, and sometimes your file doesn't get downloaded, so you just need to, so in that case, okay, if this downloading gets stuck, just open this. Okay, just open this and see, uh, it's taking little time because of internet problem, but your model will start downloading. Okay, see, it is getting downloaded. Okay, so now you just need to, after it will download now, you paste this file under this models folder. Okay, and sorry, and it will work. Okay, so now let me interrupt this cell uh, and let me cancel this downloadation and let me store that file back again here. Okay, oh sorry, and here we go. Okay, now let me run this again. It will take some time, and I'll explain you how transfer learning works. Okay, like how we excluded the top layer, but basically what we will do. Okay, but what we will do, I'll explain. Okay, now see, base model dot summary. Okay, see the summary same like this. Okay, console 2D and bottleneck, like see console 2D, and like see this is the input layer. Okay, and then you will see the best normalization and this one. Okay, expanded conventional. If you learn little about Mobilenet v2, you will understand it. Okay, see, and let me open this up, and you will see the notice that batch normalization means normalizing your weights and padding, and you can say activation functions are applied regularly here. Okay, so see, now see the last layer has been excluded. Okay, it might have here 1000 basically something. Okay, and see what it has written here is see impact of bottleneck and all you can read it. Okay, but basically last layer has been excluded, and see right now this is non-trainable parameters is this much only. Okay, and rest are all the trainable parameters, means these parameters. Okay, uh, around 22 lakh are trainable, which should not be there. Okay, because we don't need to train any of this thing. Okay, we are not going to train any of this thing. Okay, why? Because how transfer learning works, how transfer learning works. Okay, you will see, and what will happen when we will add our own layer. See, transfer learning works is basically, see, in the traditional ML now, if I click this, I'm sorry my internet is little slow right now. See, in the traditional ML now, what happens is basically you train it for, let's say this is traditional ML. Okay, you train it for, let's say, cats versus dogs. So your first system is having the knowledge of cats versus dogs. Your second system will be having the knowledge of, or your second model is having the knowledge of horse versus donkeys. Okay, means for the cats versus dogs you need to train it from scratch, means every parameter. For horse versus donkeys you will need to train every parameter from scratch. But in the transfer learning now, when you will, let's say dataset 1, let's say when you will train your model for cats versus dogs, you will apply the same knowledge, means the feature extraction. What is feature extraction? The color of the dog and cat, the size of the dog and cat, the age means that EDGE na, means of course the shape, the age of that shape, okay, of cats versus dogs, the size, okay, everything, how the nose looks and all, okay. So means your model is having the knowledge of how to differentiate and or how to recognize color, shape, size and every parts of the body. You will apply the same knowledge for the horse versus donkeys. What happens is basically your accuracy will get increased, okay, because you are not going to teach your model that this is how you need to recognize the color, this is how shape looks like, this is how size is defined, okay. It is already having the knowledge of cats versus dogs, okay. So in that case, what happens is basically the accuracy will be increased, okay, and you don't need that number of data set, okay. Means you can train it with a small number of data set only, okay, because of course it is having the knowledge of the cats versus dogs, so it's easy for the model to recognize or to differentiate between horse versus cats using even less number of data, okay. Now what is feature extraction? As I said now, it is having the knowledge of cats versus dogs, okay. But see, the thing which I am going to tell you is where it is. Let me find something, okay. Okay, see what happens is this is our model, okay, which is having the knowledge of thousands of classes. We will remove this, you can say this three thing, okay, we will remove this, okay, and we will just keep this one. As I said now, oops, okay, as I said now, we will just remove the last layers, okay, and we will keep the rest layers. Why? Because in the rest of the layers is having the knowledge of feature extraction, means the colors, shapes and size, okay, and only the last layer is used only to predict, only for the prediction, okay. So we will remove this layer, we will add our own layer of two output neurons, okay. Right now it is having thousands of output neurons, we will just add two for to differentiate between with mask or without mask, okay. And we are going to keep everything same because it is having the knowledge of feature extraction, okay. So we are going to extract the features and then we are going to predict only two neurons, okay, basically two output uh, two outputs basically with mask or without mask, okay. So include top equals to false means we have already excluded it, okay. Now see, this is our feature extractors, okay, this is our feature extractors, okay. So it is having the knowledge of thousands of classes, okay, and it knows how to extract the features, okay, means it will just see basically the data set of with mask and without mask, okay. And let's say it will just see the data set and see, okay, it will just extract the features. Oh, okay, this is mask, this is mask, this is mask, okay, that's all. And the layers which we are going to add is just for means it will just predict, okay, between two output variables, okay. Now head model, this was the base model, right? Head model means the thing which we are going to add is base model dot output, means whatever the output it will give, we are going to apply for the next layers, okay, as we are adding the next layers, okay. Head model is equals to average pooling. Now what is average pooling, okay? average, which I didn't run basically, I think. Yep, I think, yep. Average pooling, sorry, average pooling 2D. Okay. Now, what is average pooling? Let me just write and I'm going to explain you. Okay. To 7 by 7 with head model. Okay. Okay. Now, what is average pooling? Let me average pooling 2D. Okay. Basically, we use max pooling most of the time, but in that case, it is given average pooling. See, let's understand the max pooling. Average pooling is basically same. Okay. See, this is your CNN. Now, this is your block of features. Okay. Means in the let it load. Okay. Means this is your block which contains the numerical features like that data, right? That data which you are having right now. Okay. So that block of CNN contains this data. Okay. So what it will do is basically it will make 2 by 2 block. Okay, like we give 7 by 7 now. We just give 7 by 7. Where it is? Okay, 7 by 7. It will make 2 by 2 block. It will go to first this 2 by 2. Okay. What is the maximum feature here in this? 9. So it will take 9 from here. Okay. It will similarly go to the second block of 2 by 2. Okay. What is the maximum feature here? 7. Here 8 and here 6. Okay. Rest it will ignore. Why? Because we only need maximum feature. Okay. To predict, means of course if nose is enough to predict who is that person, then we will take nose only. Okay. Why? Because if we take every feature, then it will increase the complexity of the model. Okay. And it will increase the size. It will take it will take you know it will have a computancy cost. Okay. So that's why we are going to use just a maximum feature. Okay. And rest of them we are going to ignore it. This is the case for maximum pooling. What is the average pooling is basically, see, it will go to the block. Okay. What is the average of 0 0 2 2? 1. Okay. What is the average of 2 4 6 8? 5. What is the average of 9 3 7 5? 6. What is the average for 2 2 2 2? Simple. It will take the average features. Okay. If that image is not that much clear, then you can see it's loading, still loading. Okay. So that's why, like, that's how average pooling works. Okay. So head model is basically we are going to apply this average pooling function there. Now head model is equals to flatten. Now what is flatten is basically, see, name is equals to flatten, means we are just giving the name. Okay, nothing else. Head model means, see, this is your head model. Okay. Now what is head model? Head model, whatever the, see, right now it is 1 to 80. Okay. 7 7. What does flattens do is basically, now it will flats the layers, means 1 to 80, like it is like this right now, 7, then here 7, then here 1 to 80. Okay. Once it will flats this, now they will come into a single line. Okay. So 1 to 80 into 7 into 7, it will become like that. Okay. If you want to see the flatten layer, see. Okay. Oh, sorry. Okay. See, this is the flatten layer. Okay. See the boxes of conventional layer with its max pooling or average pooling, and then this box just gets flattened, the pressed, like a pressed, like a iron. Okay, oops, or even you can see here. Okay, the more cleared image, let it just load. Okay, see, right now it is having lots of neurons, and now we are just flattening it before giving the output. Okay, that's all. Okay, so when we will do model.summary, now you will understand it better. Okay, now head model is equals to dense 128 means, see, what we are going to do is basically, after it will get flattened, after it will flatten the layers, we are just connecting 128 neurons of layers. Okay, which is called dense layer, means this is just a normal layer. Okay, like this, what we are doing, we flatten, and then again we are creating 128 neurons. Okay, like 1 2 3 4 128 neurons. Okay, simple. Like, see, okay, conventional layers. Okay, and then the flattened layer, and then again the dense layer of 128 neurons. Okay, that's all. And the last, no, not the last, but basically head model is equals to dropout layer. Now what is dropout? Dropout 0.5 of head model. Oops, I didn't add it, head model here. Okay, means head model into head model, means of course add the dense layer with the head model. Okay, and now add the drop layer with the head model. Now what is drop layer? See, what is drop layer is basically drop out layer. Okay, it's simple, it prevents your model from overfitting. Okay, means the overfit thing. If you don't, then what is overfitting? What is overfitting? Okay, in CNN. Okay, underfitting doesn't happen in CNN, only overfitting. Dropout is a technique used to prevent a model from overfitting. Dropout works by randomly setting the outgoing edges of hidden units to 0. Okay, neurons that make up hidden layers to 0 at each update of training phase, means in per epochs. Okay, overfitting. What is overfitting? Overfitting happens when your model fits too well to the training set. Okay, means if your model performs too better in your training set, but doesn't performs well in testing set, in that case it is called overfitting, because the network has memorized the training examples, but it has not learned to generalize to niche situations. Means your model has memorized only. Okay, it has not able to generalize, means it is not learned, but it has memorized. Okay, so we don't want that basically, because it will uh, go perform good in a training phase. Okay, because it has memorized the patterns, but it has not learned the patterns. Okay, it has not understood. Okay, so it will not perform better in the new data, basically test data. Okay, now what is dropout layer is basically it's simply, as it said, works by randomly setting the outgoing edges of hidden units to 0. Okay, see, it's simple. See this. Okay, sometimes see the okay, this, oops, see, it is a standard neural network. Okay, so in each training epoch it just drops the parameters. Okay, it just drops the, you can say, the layers. Okay, and it just trains with only some number of layers. Okay, so that it doesn't you can say overfits. Okay, it's simple. And see, okay, standard and network after dropouts, it gets simple. Okay, it doesn't overfits. Okay, it generalizes well, it doesn't overfits. Okay, so now let's head model. Okay, and now one last layer we need to add. Head model is equals to the dense layer of the two neurons. Okay, two, because we have only two output. This one is the last thing we need to write. Softmax function. Okay, if you have let's say only one output neuron layer, means if you have either uh, you can say if there is something or not. Okay, or you can see if there is only one output neuron, then you use sigmod function, and this softmax function and is used for more than one output neurons. Okay, what is softmax function? Softmax function is basically, see, it's simple. Okay, it is the activation function, means, okay, now let's see. If your model thinks that it is 60% sure that this person is wearing the mask and 40% sure that that person is not wearing the mask, so your model thinks that 60% I am sure it is wearing the mask, so we will get output that this person is wearing the mask. Okay, so that's how softmax works. Okay, 0.5 means the 50%, it is having threshold. Okay, means let it load. See the threshold 0.5, 50%. Okay, this all comes down to with this. Okay, 0 or 1 means if you have any kind of probability, if it goes above 50%, then only it will activate that neuron. Okay, otherwise it will not, means only it will, then it will see something. Okay, or see, okay, let it load. See, in this case it is having three output neurons. Okay, three classes. The model thinks that it thinks that the first one, means let's say if we are classifying animals, then the model thinks that I am 70% sure it is dog, 20% sure it is cat, 10% sure it's horse. So according to this, okay, what is above than 50%? The dog. So that image will be, or that animal in that image will be considered as dog. Okay, that's how softmax works. It's simple. And now activation softmax means, uh, see, we have two output neurons with mask, without mask, and whoever goes more than 50% will be declared winner. So head model, what is head model? The dense layer of two activation function of softmax in the head model. Okay, this one. So what we did is we removed the last layer, and we added average pooling layer, flatten layer. We added 128 neurons of dense layer, we dropped out, and then we used dense layer of 2. Okay, now what is our final model is basically, see, what is our final model? The capital one which we imported, and inputs. What is inputs? Inputs is the base model dot input. Okay, and what is its output is basically head model, means, see, what is its input is this base model. Okay, this is the input, and what is the output? The head model, the last one. Okay, this one, the two last. Let's run this, and tuple object is not defined. Where head model pool size, oops, and it will to, and yeah, and the dance at the last, unknown activation from softmax. Oh, it's in the, okay, again a problem. input base model, not on inputs, it's input. Okay, no, inputs, it basically inputs equals to, yeah, one more thing, it's here the outputs basically. Okay. It was showing the input but it was the outputs. Okay, so now see the model dot summary. Okay, summary, and see, you will see the difference. Everything is same but the last, okay, last it was having this ReLU function of 77128. After flattening this, okay, after flattening this, it becomes 11128 1280 basically. Then sorry, this is the average pooling. Okay, and in average pooling what it did is basically it took out the average. Okay, so it become 111280, then flatten 1 into 1 into 1280 only. Okay, dense layer of 128, this one. Okay, this one it is there. Okay, dropout of 0.5, okay, 50%. Again same, the dense layer of 2, the two output layer, sorry, the two output neuron of that layer, okay, with mask or without mask, it will see here. Okay, and at last total parameters are 24 lakh around. Trainable, how the trainable parameters are 23 lakh and non-trainable is 34,000, but we are not going to train this much of parameters, because why? Because as I said, only last layers are need to get trained. This one, okay, this from average pooling 2D to dense layer, okay, this one, and rest we are not going to train. So basically what we need to do is this, not model or summary, add here what, for layer in base model dot layers. Okay, in the base model, okay, in that layers, layer layer dot trainable is equals to false, means we are not going to train the base model. What is the base model? This. Okay, now see trainable parameters is now only 1,64,000 and non-trainables are this much. Okay, 22 lakh. In the 24 lakh 22,000 we have 22 lakh 57,000 non-trainables, means now this 22 lakh 57,000 are just a feature extractor, and this 1,64,000 means this one. Okay, from our average pooling to dense layer, if you count the parameters now, you will find like this. Okay, 1,64,000 are just trainable. Okay, so means we are just going to train from this average pool to these two, and rest are just a feature extractor. Okay, that's all. So now the last thing which we need to do only before we start our training is, let's train the model basically, right? But first we need to just do little thing. Okay, like what is the learning rate, what should be the learning rate of the model? Okay, learning rate is basically, let's say we defined 0.001. You can see how fast your model learns. Okay, how fast it reaches to, you know, minimum loss, means minimum error, you can say. Okay, this is, you can debate for 0001 or 001 or 001. This one is also standard. Okay, you can basically play with it. Okay, these are the fine tuning things now. And what is the number of epochs, means how many times you want your model to go through, you can see your images. Okay, let's say I define 20. Okay, and okay, that's all. And batches, yeah, batches, how can I batches you can say batch size, but batch size is you can say um, batch size, let's define like this. BS is equals to means how many images you want your model to train at once. Okay, it depends highly on your RAM. Okay, so let me just take 12. You can take 4 8 2 4 8 16 and all. Okay, let me just take 12. Now OPT means optimization. What is our we are giving OPT just as a variable Adam. What is Adam optimizer? You can just simply Adam optimizer. Okay, you can learn that and see how it optimizes your how it reaches to global minima. If you understand, if you go through the little about CNN, how CNN works, you will find it. Okay, but as a absolute beginner, if any beginner is watching, I am not going to do that. In the simple words, it just you can say how well it will optimize your your model. If you do plus, see all, you will see the parameters. Okay, so I'm just going to give what is my learning rate. This learning rate, let me do this as I've done this earlier. Decay means the number of steps, you can say. So the no, not the number of steps, basically it's epoches. Okay, okay, now see model dot model dot compile. Okay, uh, compile. Now we are just compiling the model. Okay, before fitting binary optimization. Binary, why? Because we just have two classes like 0 and 1. Okay, if you have multiple classes, you can use categorical cross entropy. Okay, cross entropy and optimizer, which what you are going to use. OPT means, of course, that optimizer Adam with this much learning rate and decay, so that your model doesn't get diverged. And with what matrix? Accuracy. You want to see the accurate, how much accurate is your model. Okay, so accuracy. Now last, H is equals to, I'm just giving the name model. Well, we don't need to give, but give. Okay, model dot fit. Here we are going to start the training. Model dot fit means first model dot compile, we compiled it. Okay, now model dot fit, which we are storing in the H. You can store this to make the graphs, basically. Okay, to make the graphs. Okay, the notebook which I will give, it will contain the graph. Okay, you just need to define the path. Okay, model dot fit, let's fit it and see. AUG dot, that data augmentation, AUG is equals to image data generator. Remember the AUG dot flow how? Train X with train Y. What is our batch size? Batch size is equals to BS. Okay, that is 12, comma, steps per epoches. Okay, how many steps you want in per epoches? Length of our training set divided by the batch size. Okay, validation data. What is our validation data? Validation data is equals to test X, means of course you want to validate your model. Okay, test Y, test Y, and validation steps. Okay, Validation steps, how many steps you want for per validation? So it's again simple, it's test test x divided by the batch size again, okay, and how many epochs is there? That is epochs, okay, means the 20 basically, okay. So now h, when I will give you graph, you can make it here, but you don't need to store this in a variable. You only need to store this when you are going to plot, okay. Now you want your model to get saved, okay. So model dot save, and so that you can use your model anytime now without training it again and again, and there you go, okay. And your model will get saved here with let me give this name, mobile net v2 dot model, okay. And after this that's all. After training, your model will get saved here, and just after let's say, yeah, after saving your model, we want to predict, okay. Predict on like, see, model dot predict on what? On the test data, okay. And what is the batch size? Basically batch size equals to bs, okay. But first, okay, now what you want, you just want to go for like np dot argmax. Argmax means which output is having the maximum probability, like, you know, that which output is having maximum probability with mask or without mask, okay, of the particular image, or even in the video, what if you are wearing the mask or not, okay. That's all. So you just want to print a classification report, okay, of that test data. Classification report, not class method, classification, okay. We have not imported a classification report, I guess, right? So first let's go here, from sklearn dot matrix, okay, import classification report, okay. There we go. Classification report, I think I've write, okay, report of what? Of compare your testing on the test data with its labels, okay. Means it will predict if it on the test data of that 20%, and it will compare its result with the true value, okay. It will compare the predicted result with the true value, okay. Means it will predict if that person is wearing mask or not, and in the actual, okay, let's say if it predicted that person is wearing the mask, in reality if it is not, then of course the accuracy is not there, right? So test y dot argmax, the maximum argument x is equals to 1, and predict of that, of course, that argmax with this argmax, and the target names. What is the target names? You know, lb, what is lb? Label binarizer, and the classes, okay. Means compare the with the test y, okay. What is that, you know, the maximum probability with it with the predict, okay. And in the predict, what outcome it is showing, okay, the maximum probability, that, you know, probability is the maximum that it is the person wearing the mask or not. Okay, target names, there are basically two target names, 10 and 01. Okay, that's all. Let's run this and then it will get run. So your training has started. Okay, training has started, and see accuracy. I don't know why there is 95% accuracy in the first approach, but okay, let it train. Okay, that's all. Okay, see here, our training has been completed. Accuracy was revolving around 97-96%. Okay, loss 0.07%. Okay, and validation loss is 0.10%. Validation accuracy is also revolving around 97-96%. Let's see the classification report when it predicted on their 20% test data. With mask, without mask, precision 96%, 99%. You can see. Okay, F1 is scored this much. Accuracy overall 97% we got. Okay, on the test data. Okay, then you can say macro average, weightage average, and all. Okay, so yeah. Okay, now you can see the classification report of 97% accuracy, precision, recall, and everything. Okay, and let's see, and your model has been saved here. Okay, Mobilenet v2.model. So now let's test this model. Okay, so let's start the testing. I've just renamed it. Okay, mask training and then mask testing using images, and then we will write the code for mask testing using videos. Okay, well, if you want, I've given the code. You can simply test it. Okay, if you don't want to write from scratch. Okay, you just need to change some path. Which model did we use? Mobilenet v2. Okay, and I'm going to import pre-process input. Okay, now I just need to model pre-processing dot image. I'm going to import image to array. Okay, to convert all the images to array, of course we need to convert, right? And then models, I'm going to import load model. Okay, to load this model which we saved. Okay, this is our Mobilenet v2 model. Import numpy as np. I'm going to import cv2, and I'm going to import at last os. Okay, from okay, all good. Now let's load our phase detector. Okay, this phase detector which we gonna use. Okay, we are not going to use Haar cascade. Okay, which we are not going to use Haar cascade. We are going to use the better model. Yes, this cafe model is actually a lot better than Haar cascade in terms of detecting faces. Okay, I'll make a video on face detector using this cafe model. Okay, to use this we need two files, basically this cafe model and this proto.txt. Okay, is it? Yeah, proto.txt. Okay, now let's call them proto.txt path. I'm giving this name os.path dot separately dot join what? Join this. See what you need to write like this. Okay, it's not like you need to write, it's the same. And comma, what is the model name basically here? What is the model name? Deploy proto.txt. Okay, deploy dot proto.txt. Okay, then square, then parenthesis. Similarly, weights weights path. What is our weights path? And just copy this, and I'm gonna paste this, and then I'm just gonna copy the name. Copy the name and just put this, and then dun, dun, dun. Okay, now this 2 has been imported. Okay, and see, if you call their path, okay, if you call their path p, okay, see Python 37 projects face detector, and we have this, and in my path they are like this. Okay, now see face detector under that. So we have imported 2 main files to detect face. Okay, now net is equals to see what I want to see in a we need this 2, okay, to go through our deep neural network DNN, okay, so that it can detect face. Yes, this is not Haar cascade, okay, this is like SSD, single shot detector, face detector. This face detector is made up using deep learning, okay, so that's why it needs to go through this deep learning thing. Okay, read net, what it need to read on this potato. Wait, it's potato. Why it's why I named potato? Proto txt and proto txt. Okay. Oh, sorry. Okay. Read net and potato proto txt path and this waits path. Okay. Oops. Why I'm so lazy? Waits path. Net no, read net. Oh, it's capital N. Okay, now if you call this net, it's just a you can say function. Okay, it's just a class. Now let's load our model. Main model. What is our model? Basically this Mobilenet v2, right? So I'm just gonna copy the path, I'm just gonna paste it. No, not like this. Load model, and R. Python takes everything in the forward slash. So if you put R, see, I have done it using Mobilenet v1 model also. Okay, well, Mobilenet v2 model is better because of cost. It's the better version of v1 model. Okay, model. Okay, all right. Now we have see, model is loading. Okay, now till let's test, let's load our test image. Okay, in which image we want to test, right? Read function does what? It literally takes your image and convert them into array. Okay, okay, oops, what is happening with me? Okay, okay, so read, and then we'll just copy the path, and no, where is that? Examples. Okay, yeah, we will use some images to test. Okay, let's say we will first use this example 01 image. Okay, example underscore 01 dot, I think it's jpg or png. Okay, it's png image, so dot png. Okay, if you're hearing right now some noise like hammer, na, so sorry about that, construction work is going on. Okay, so see how does it works. Okay, see, the image has been converted into array, into machine form. Okay, like in the machine language, the model understands everything in the numbers. Okay, like you remember now, even in the training we converted image to array. Okay, so now see, let's go for its what? It's see, image dot shape. Okay, again, if you're hearing some noise, then I'm sorry. See, image dot shape, if you do this, see, see image.shape, the shape of that image, okay, which we will resize, okay, and yeah, 600 by 500, okay, means of course same. And 3 is the channel, that is RGB color, okay, but we need only this two, this 1 and 2, okay. So what we will do is we just need height and width basically, right? We just need that, and here we go, height width is equals to image 2, okay. So we just needed that and we got this, okay. Now we are going to pre-process this, okay, using a blob function. Now what is blob function is basically, you can read about it from here. I'll give you the link, of course, the face mask detector and this, how the blob function works, basically blob from image, okay. Basically, see cv2.dnn means in a deep neural network it happens, okay. Of course the face detector has made from, the deep neural network, but see, okay, but see blob from image, okay. Let me explain you. What happens is, see, we are going to pre-process it, okay, means we are going to scale down this data, we are going to resize this, okay. Like see, for you can say, yeah, okay, we are going to resize it, okay. Right now this one is having size of 600 by 500, we are going to resize it, okay. What we are going to resize? This image, okay. And we are not going to see, this one is the scale factor, okay. If you press shift plus tab, you will find image, then the scale factor 1.0 means we are not going to scale it, we are just going to simply subtract it, okay. Then size, mean means from what factor we are going to scale it, okay. And then swap RB, I'll explain you, okay, don't worry. Then see, 300 by 300, okay, resize. Now see, if you read this now, you will understand it. How this basically works is basically where it is, okay. See, size then mean, these are a mean subtraction values, okay. They can be 3 tuple of the RGB means, or they can be single value, in which the case the supplied value is subtracted from every channel of the image. See this one, okay. See, R is equals to R minus mean of R and G, and similarly see, okay, their mean they subtract, and that means the data gets scaled down, okay. You can read about it more. 1.10.4 R G, this works in RGB way, okay. Our image might be BGR, okay, and so that we listen, our image is in BGR, okay. The channels are different, it is in BGR, and this needs to be in RGB, okay, for the resizing purpose in this blob, because blob takes in RGB, okay. The good thing is, see, either you want, you can do like either you want, oops, then you can swipe the channel, okay, this swap RB, okay, red with blue, but by default this function will do it, okay. Okay, and I think everything done, okay. Now see the blob, see the way it has been recycled, okay. 186, 183, 145, and see it has been subtracted with its mean, and see 81.76 okay, something like that, okay. Now it's not much scaled down, of course, it's just like in a float way, okay. See this, okay, it's now in a float. Earlier it was, in the integer type of form, but we have done pre-processing, okay. We have resized it. If you see blob dot shape 300 by 300, okay, it's now in the 4th dimension. 1 2 3 4, 3 channels, basically RGB4. It's in the 4th dimension. Now we need to give this blob to our deep neural network. Okay, the model which we have trained, right? This one, this to detect the face. Okay, this is the image in which we need to detect the face, and how we need to detect using this net. What is net? The combination of these two, na, the face detectors. Okay, so see, net dot set input blob is the image, the resized image, and net is what? That, na, this one, this net is equals to this. Okay, in which we have we have applied the face detector. Okay, detections. Okay, detections is equals to net dot forward. We have given this now in that deep neural network. Okay, in which we are now you can say detecting the face. If you just see this, okay, the face, this is the face, this is the array of the face, you can say. Okay, now many things have been done, and see now what we have done. Now what we have done is basically, till here we have you can say imported face detectors, we have imported load model and the image, test image, we have resized it using blob, and we have given blob in the neural network to detect the face, and this is the face, you can say. Okay, now let's predict you can say the face, means if that person is wearing the mask or not. Okay, now the last step, loop over the detections. Okay, these detections, loop over the detections. Now for I in range 0, from 0, detection dot shape 2. Why 2? Basically it's simple. See, we need this, na, 2, this. Okay, that's why dot shape. Now under this, okay, now we will extract the confidence. Now what is confidence? If you know, if our model thinks that it is 60% sure that that person wearing mask, so we will get the output as yes, this person is wearing the mask. Okay, the threshold value is 50%. Okay, so if confidence is greater than 0.5, means the 50%. Okay, then we will do. But here, before that, first of all, we will need to extract the confidence, that is the probability associated with the detection. Okay, so confidence is equals to detections, and this is the index value. Okay, 0 0 I 2. Now okay, now if confidence is greater than 0. Means if that detections and its index is greater than 50%, you can say, then what it will do, now it will compute the xy coordinates of the bounding boxes for the object. Okay, means see, it will detect the face, but to detect, see, it will detect the face. Okay, but now it's need to compute the xy coordinates, the coordinates of the bounding box for the object. Okay, object means the face. Box is equals to detections. This is how you need to write I and 3 7. Just have patience. Okay, just write with me, array and w height and w height again. Okay, and yeah, no, why I don't need to reload. Okay, now this is the box. Okay, this is the bounding box of, you can say, we have computed the xy coordinates. Okay, now this is the bounding box. Now of course we need what we need the x and y coordinates. Okay, now from this box we will get the x and y coordinates. Okay, like this. Start of x, from where x has start, from where y has started. Okay, and end where they have end basically. Okay, and y where, from where, box dot s type integer. Okay, int. Now, okay, now we need to ensure, see, now the frame will open. Okay, the window will open in which we will see ourselves. Okay, basically the image. Okay, we need to make sure, okay, we need to ensure the bounding boxes fall within the dimensions of the frame. Okay, we need to ensure that those box needs to be under the frame. Okay, so it's simple. Start and equals to, we just need to set something like, say, 0, maximum 0 to start x. Okay, and maximum it should go only 0 to start y. Okay, sorry, and then int and ending is equals to minimum w minus 1. Okay, with minus 1 with end x. Okay, and minimum height minus 1 and comma end y. Okay, and let me just give some space so that okay, now we have ensured. Okay, let's run this. But let's continue from here. Okay, now we have ensured that the bounding boxes fall within the dimension of the range. Now let's predict. Okay, means what we did, we set the threshold value of 50%. We detected the face. Okay, we did all the things. We detected the face. Now the confidence, okay, is greater than 50%, you can say. Okay, then what we need to do is basically predict. Let's predict, right? First of all, not here. Extract the face ROI and convert it from BGR to RGB channel. Okay, now here we need to convert it BGR from RGB channel, ordering, and we need to resize it, to what, 224 by 224. Why? Because here we have trained it for 224 by 224, right? It was the inputs, it was the input. Okay, see, we resized it now. Okay, so okay, and pre-process it. Okay, now face is equals to image start. Okay, image start from end and end here. Okay, and start of x and end of here. Okay, now face here we need to convert. Okay, from BGR to RGB. CVT convert color. That's how basically you need to convert. Okay, CVT convert color. Face, convert the face. Okay, this is the face in the image. Okay, and this is the coordinates of the face. Convert the face cv2 dot color, that's how you need to convert bgr to RGB. Okay, now phase equals to cv2 dot resize it phase and resize in our trained, in which we trained it, right? Now convert that into array. Basically, of course, after resizing the image, we need to convert it into array, right? Image to array, phase, and now pre-process it according to the our Mobilenet v2. Okay, phase is equals to pre-process input of phase, and now expand dimension because it has 3 channels basically. So expand numpy dot expand okay, all right, why, okay, expand dimensions phase, of course, because it has 3 channels and all. Okay, so now we have done almost many things, and the last point only, the last, not point, but basically this is the phase we got. Okay, now let's predict if that person wearing mask or not. Okay, mask without mask. Okay, with mask, without mask. Okay, is equals to model dot predict phase. Just show the first result which we will get. Okay, now let's determine the class label color and color we will use to draw the bounding box. Okay, let's determine the class label and color we will use to draw the bounding box and text. Okay, now label is equals to mask, show the mask. Okay, means label it as mask if mask is greater than without mask. Okay, or else show no mask. Okay, else show no mask. Color, what color, in which color, 0, RG, in the green color. Okay, 255 is the maximum value of any pixel. Okay, that's why if label is equals to mask, else in the red, and else show in the red color, that if that person not wearing the mask, na, show in the red color, BGR. Okay, now let's include the probability in the label. Okay, means we will see the probability also, like this, like this. This is the if you know the basic string format, you will get what I am writing in okay, dot format label, show the label, and max, I should silent my phone basically. The maximum, okay, mask, the maximum probability show. Okay, without mask and into 100. Okay, now display the label, okay, and bounding boxes, first we determined everything. Okay, now in the frame basically. Okay, now we need to display also, right? Put text in the image label. Okay, start X, and where we want to show. Okay, where bounding boxes will be start -10, means, you know, in the Y, just below, like, you know, 10% thing. If as a beginner, if I want to explain, okay, means just write above the bounding boxes we want our labels. Okay, so start of x, start of y, just a -10, okay, of y. CV2 dot, you can play with it, okay, then you will understand better. In what font we want? Font you can say Hershey Simplex only, okay. In what form? And now we are just determining the thickness and all, okay. The thickness and the color, okay, color is this, okay, only 2. Now CV2 dot rectangle image. Now rectangle, draw the rectangle, basically image, start of x, comma, start of y, end of x and end of y, color and 2, okay, rectangle in that color basically again, okay. Means if mask is there and then the color this, okay. If label is marked then green color, if label is not then red color, okay. Now the last 3 lines basically, which is very important. CV2 dot IM show the output named as output, okay. Let's name it output. Image, show the image, okay. CV2 dot wait key, any key you will press, it will destroy the window, okay. It will destroy all windows, okay. Okay, let's run this and see if we get any error. Oops. Okay, it's running, okay. Now let's see what error we get basically, okay. CV2 no rectangle, okay, in line number 35. Oh, where I'm not even able to see. Okay, here now. Rectangle, for the spelling, is it EL or is it EL? Oops. I think it's LE, right? Okay, C. C, mask, 100% probability, okay. The thing which we wrote now here, include the probability in the label, okay, 100% probability, yes. Then see, display the label and bounding boxes, start x, start y, -10, okay, means just at the bounding boxes, okay. You can play with it, you will get this one above here and all, okay. Let's try different image. Example 02, okay, let's try that. And 02, which is not no mask, okay. So basically we have tested, okay, we have okay, see, this one is interesting for the 2 faces, okay. For the 2 faces, where it is, sorry, yeah, 3, okay. No mask, 100%. This one is not, this simply not detecting, this one is detecting but this is not, okay. So yeah, things happen, okay. We can retrain it by using different kind of sizes, okay, different sizes, like we trained it using 224 by 224. You can retry that, you can train it for more, okay, basically, or you can train it for more number of approaches. Basically we got 98% accuracy, right? Okay, we got some not misclassification you can say, but no detection, okay. Okay, so we did it for images. Let's do it for the what? Let's do it for video, okay. Mass testing using video. This one is the last. Oops, what we are writing? Copy, copy, okay, and this one. You no, it's the video. video. Okay, see, we just need to copy something, like some path only, something we need to write, something we need to copy basically. Okay, from I am utils dot video. Okay, we're gonna import video video stream. Okay, from I am utils utils, and we're gonna import nothing else. Okay, if I'm not wrong. Yeah. Now let's make a user function called detect and predict mask. Okay, and frame the face net. Face net will be basically our face detector model, that cafe model, and mask net is basically our model. Model means that mobile net v2 model. Okay, now grab the dimension of the frame and then construct a blob. Again, what is blob? You can read about it here. Okay, now we need height and width. Height and width, it will show in the 3 dimension, right? In the 3 dimension we just need the 2. Okay, frame shape, the first 2 we need, height and width. Okay, I not let you basically here. Okay, we needed this comma 3, it will show like this. Okay, so we just need the first 2. Now same basically we will do same here, blob, but frame, the video frame, right? Frame 1.0 300 by 300 and the mean. Okay, the mean of RGB. Okay, now this, what we will do is basically yes, we'll just need this. Okay, face net means that our model, that face detector, right? Face net dot setup blob and detection is equals to face net dot forward. Okay, now under this we will write this. Okay, we will make 3 things. Initialize our blob through the network, and initialize our list of faces. Okay, list of faces, their corresponding locations, and what we need, list of predictions. Okay, predictions. Okay, so faces equals to empty list, we will get the list. Okay, this is what their locations we will get in the list, and the predictions, okay, we will get in the list. Now again we will just do copy paste stuff. Okay, from for I in region detection dot save confidence, if confidence 0 greater than then numpy dot array integer, and we will copy this one too. We will, okay, till here first let's copy. Okay, all good. Now extract the face or ROI. Now pre-process, what we will not do, resize image to array, we don't okay, we will do this pre-process, we will not do expand dimension, right? So copy this, and okay, instead of image we will write frame. Okay, just wait a minute, let me just copy whatever is needed, not much needed. Okay, now for I in box type, and then this frame. Instead of image we have frame, video frame, frames, convert color, okay, face color, resize face, image to array, pre-pro, okay. Oh, that's all. Now faces, that in the list we will just append the list of faces. Append means we will just fill this empty list, okay. We will append it, okay. Face means this face will go to this faces, this, okay. So faces will be face, and location, their location dot append append this one, okay, the location of the face, okay. Now out of this only, let me do this, only make a predictions if at least one face was detected, okay. This is in, we are doing in the video, okay. If there is face, then only make the prediction, of course, okay. Otherwise don't just simply say there is a mask or not, okay. Length, if length of face says is greater than 0, okay, then only. Now faces is equals to numpy dot array. We are converting it in the float 32 numpy array, okay, of course, to make predictions. 32 and preds equals to masknet. What is masknet? We will deploy it, okay, don't worry. masknet dot predict, we are making this under a function, okay. When we will call this function, it will do everything, and it will predict also, okay. Predict the faces, and the, what is the batch size? Basically batch size is 12, okay. Now return a now what it will return? It will just simply return location and prediction, okay. That's all. Now let's run this. Comfy, where oh, okay, this one, okay, sorry. Oh, it all comes under in the for loop, right? Oh, okay, I did something wrong like this. Okay, I'm pausing the, not pausing, okay. I'm not pausing, I'm not going to pause. You bear this for 2 minutes. And yeah, and this, okay, ran completely. Now let's load this, our masknet and facenet, basically, right? Let's load this one. Where they are that's all. And net is equals to, basically this is our face net, okay. Now let's load our let's load our masknet, right? The model, we are naming it masknet, okay. Masknet means this face net and this masknet will go simply here, okay, and it will do its work. This under the frame, under the frame, the face detector and the model, in which means this, in the model will recognize mask or without mask thing under the face detector, under the frame, okay. It is going in the blob and all, okay. And the confidence threshold is this much and all, okay. And then it will resize and do everything. It will ensure the bonding boxes fall within the dimension of the frame, then this, and that's all. Okay, so mask connect equals to load model. Okay, it's loading. Now VS, video streaming. Okay, we imported now from utils. Oops, video stream. Okay, src equals to 0 dot start. Now while video streaming is going on, okay, while while true, okay, grab the frame from the threaded video stream and resize it, okay, to have maximum width of 400 pixels. Okay, frame to have a maximum width of 400 pixels. Okay, grab the frame from the threaded video stream and resize it to have a maximum width of 400 pixels. Means we are going to resize the frame basically. Okay, read the video stream, frame is equals to, and this is the frame which we are talking. Okay, this is the frame. Okay, this, so we use three things: frame, facenet and masknet. And we have the facenet, we loaded the masknet, and now we are working on the frame, and we will give this 3 into that function. Okay, into that function, into this function, detect and predict mask. Okay, let's read frame is equals to I am utils dot resize what? Resize the frame, and what should be width? 400. That's all. Okay, now detect faces in the frame and predict if they are wearing mask or not. Okay, now locations and predicts, which you know, this one, what we returned here, this, right? So predicts. Now we are going to use this function. Okay, this detect and predict mask, frame, facenet and masknet, which we are going to do. Predict mask, frame, facenet and masknet. Okay, now it will work. Okay, but now we need to, you can say, loop over the detected face location and their corresponding locations. Okay, but now we need to do some more thing. Of course, we need to display also, right? But before displaying, we need to ensure something else. Loop over the detected face locations and their corresponding locations. Okay, so for box prediction in zip locations, means we want them two together. Okay, so zip, okay, you can say for IJ box spreads, we are naming it. Okay, in location and prediction. Okay, now what is the box? Basically, what is the box, right? Box is this. Start X, start Y means the bonding boxes. Okay, that is the box. Is equals to box. Okay, now mask and without mask, there are basically two thing now. So is equals to, this is the pred. Okay, this is the INJ. You know the for loop IJ, for IJ in this print this. So basically they are there. Okay, this is the box or bonding box, and this is the prediction, mask or without mask, right? Now same thing we will do here. Okay, same thing we just need to do. determine the class label, okay, and we will use to draw the bounding boxes. Determine class label and color we will use to draw, not draw, it's draw, okay. Draw the bounding box and text, okay. If label is equals to mask, if mask is greater than without mask, else no mask, okay, means label mask if there is mask, okay, else no mask. Color is green if label is equals to mask, else the color will be red, okay. Now display the bounding boxes, simple. Again display the label and bounding boxes, okay. Again here we go. Shit, here we go, sorry. Frame, sorry for strange voices. Start by -10 CV2 font Hartley simplex 040 color 2, okay. And this is the text, okay, this is the text, and this is the rectangle which we want to draw, okay. Frame, in the frame, this is the rectangle we want to draw, X and Y. The color will be like this, if green if there is mask, no then there is red, okay. Then thickness, similarly put text, what text, frame, label, and in the bounding boxes, just above the bounding boxes, in this font 0.45, you can say, the size, you can see color and thickness, okay. Now show the last thing only, show the output frame cv2 dot I am show, name it frame, okay. Frame key is equals to cv2 dot, means if you press any key your video stream will be stopped, okay. Otherwise this is very important, okay. 0 cross ff, okay. Basically wait key means it will just wait for some milliseconds, you can say, okay. If key, that key is equals to ORD Q, if you press Q, right, if you press Q, then it will break the loop, okay. It will break the loop, okay. Now after breaking the loop, what it will do, it will cv2 dot destroy all windows, it will destroy the every window, and your video streaming will get stopped, okay. Everything is done. Now let's run and check if we got any error, okay. What we did, basically I explained everything. We made the function of frame face not masknet, and we did everything, resizing and all, okay. We set the threshold value, we sent in the blob, we converted, we resized, we converted, we pre-processed it, okay. And then this is our face detector, this is our model, and then we set up the video streaming, and then we gave these three in that function, okay. This function we made above, and then we predict, determine the class level and color, okay. We did all these things, okay, in that box, and the prediction we did, okay. The prediction is this, and then do this in the block, okay. Let's predict this, let's test this basically, okay. So let's run this, and it's running, yeah, okay, yeah. No mask. Let me put on the mask, and there we go. Okay, it's the mask. No mask. Okay, Elon Musk. So we did it, and that's how you can make simple mask detector. You first need to train, then I've shown every step, then you can test it with images and video. If you like this video, so like, okay. If you found this video useful, like, subscribe, hit the bell icon, follow me on Instagram for more updates. Take care, bye bye.